Stop.
All right. So how am I going to do, we're going to do 2 right from the top again. Okay? During class, you're asked to perform an experiment using the spring. You attach a mass to the spring and record the following data. How am I going to get the equation for that? Same stuff that we just did. So for those of you that did it yesterday, you can just sit back and watch. Those of you that weren't here should probably do these steps. Clear your L1 and your L2. Under L1, we're going to go 0.3, 1.05, 1.8, 2.55, and 3.3. Okay, so I've typed in the time under my L1. The distance goes in my L2. It was 60, 50, 40, 50, and 60. You should be able to tell right from that data what's the D value, what's the A value. Can you tell already? Like, what's the biggest value in the Y? What's the smallest? What's the average of 60 and 40? 50. So what's my D value going to be? D is going to be 50, and how much does it go up and down? 10. The amplitude is going to be 10. It was easy. Stat, calculate, sine reg, L1, comma, L2, comma, vars, function, y bars, y1. We get an A value of 10, just as Stephen pointed out, and a D value of 50. Awesome. Yeah. That's pretty easy, yeah. Okay, so that's my equation. What will be the distance between the mass and the floor at 5 seconds? Do you remember doing this yesterday? I'm going to have to graph this now. Go zoom 9 and you should get a nice graph. There it is there. Do you remember how to find the distance between the mass and the floor at 5 seconds? I'm giving you an X value.
You go.
How do you do it, Steve?
Second function calc.
Yep.
Value 5.
Very good. Second function calc. Did you have that written down on your paper?
No.
Oh, good for you. Second function calculate the value when X equals 5. Because it asked for 5 seconds. We ran into this problem yesterday. What's going to happen when I press enter?
It's going to make a nice straight line.
No. It's going to give me an error. Anybody remember why it gave me an error yesterday?
Yes, the window.
How far does the window go? Not far enough. You remember our X and our data here only went to 3.3 seconds. I got to make my X at least 5. Let's make it 6 altogether. There's my graph now. My tick marks should be 1, 2, 3, 4, 5 seconds, so it's going to be somewhere about there. Now I should be able to go second function calculate value when X equals 5. 40.85. Is that what the answer you had written down yesterday?
40.9.
40.9? Okay. Okay, Lacey, so that's how you find the Y when you're given the X. Right? That's how you find the Y when you're given the X. Now, the next one is, when will the mass be 60 centimeters from the floor for the 5th time? Brandon, do you remember how we did it yesterday when I gave you a Y value and you had to solve for an X? Do you remember how we did it? It involved the second equation.
No. No, the second equation to find the.
Yeah.
So you type it.
You type in,
No.
you go to Y equals, what do you do, Steve? Help him out a bit.
And go to Y equals.
You go to Y equals 2,
Type in 60.
Y 60.
And that's the number.
Because that's the number. You type in the Y value, and what's it going to do, Rowan? It's going to put a line right at 60.
Yay.
Then you just got to figure out where that line crosses the other one the 5th time. First time, second time, I got to go further right, don't I? So window, X max, 15 maybe? I don't know. Do I need to adjust the Y?
Yes.
Why?
No.
Why not?
Okay.
Did I not see both the max and min on my graph already? I think I did. Okay.
I'm good, man.
So there's my equation. Here's my line. So there's 60 for the first time, second time, third time, fourth time, fifth time. How do I find that spot right there? Yeah, well, you could use trace. The only problem with trace is that, first of all, it does the stats for you, and it sort of jumps too. It's not always going to be right at 60.
And you can use the max.
Okay, like it's at 59.37. It's not exactly. We don't know for sure it's at max. I guess we probably do from this time. The easiest way to do it is to go second function, calculate, number 5, intersection. The intersection between those two curves. So first curve, yeah, that's the first one, press enter. Second curve, yeah, that's the next one. Guess, yeah, it's pretty close, press enter. And it tells me that it touches 60 for the 5th time when the time is 12.3 seconds. That's how we did that yesterday. Okay? Now here's the new stuff from today. If this is my equation, right here, okay? And we've all flipped the page now to part D, where it says your teacher gives you a second spring. You attach the same mass to the end of the spring compared to the first spring. You know that it bounces higher and more often in the same amount of time. Create a sinusoidal equation which could represent this new situation. Higher and more often. So, what does that mean? If it's going to bounce higher, what A, B, C, or D value is going to change? Luke, which one of the A, B, C, or D is going to change? You know, don't give me time. He called on me.
Oh, yeah.
Yeah. If it bounces higher, the A, the B, the C, or the D is going to change. If it bounces higher, it should also bounce lower, should not? It'll be the A. So what should I make my A instead? My A should be something like what? I want it to bounce higher.
12.
Okay, 12. 12. And it also said that it bounces more often. So it goes up and down, it goes more often. Which number is the more often one?
That's your B.
It's the B. Now, what's that? Is it going to be bigger or smaller, Rowan?
Small.
We kind of don't know, really, do we?
I thought it would touch the ground less, so it would be small.
It says it bounces more often. So, like, the first one, the first graph's going to be like this, right? The next one's going to be like, it's got to be like that, right?
Like the ground changes?
Yeah, it says it bounces higher and lower.
Well,
maybe it's just higher up in the air. The D value is 50, right? So if I don't know what to do with my B, could I not just try one and then try the other and see which one works? Would that not work? How about we try that? I'm almost done. Let's go to y equals. Do I need that 60 in there anymore? No. Let's get rid of that. We're going to put a new equation. Instead of 10, we decided on 12. So 12 times sine. Now I got 2.09 for my B. Rowan thinks it's the B, and he's right, actually. You want to guess bigger or smaller, Rowan? Smaller. So 1.5?
Sure.
Okay. 1.5 x. Make sure you put your x in, otherwise you're just going to get a line. 1.5 x. Now what about the 942? Should I leave that the same?
Yes.
Remember, that's the C. That's the one that just sort of moves it sideways, the whole thing, right? So let's leave that as plus 0.942. And my D, I'm going to leave the same, my midline, right? Okay, so will my graph, there's my first one. Will the second one be higher and more scrunchy?
Sure.
Is it more scrunchy?
It's higher.
It's higher and lower, but is it more scrunchy? I don't think so. I don't think so. I think Rowan guessed the wrong way. It's all right. The best way to learn something is to make a mistake. So how about, now that we couldn't really tell the difference, how about we go quite a bit bigger? Is 15 too big, do you think?
No.
Maybe. We'll go 10. How's that? We'll go big, but by enough that it should make a difference. Okay, so here's the first one. Here's the second one. Oh, is that what we want?
Yeah.
Exactly. Gotcha. Okay.
Wait, it looks like two eyes in the
It does.
picture. Cat's eyes.
Oh, boy.
Yeah.
I'll put a smile because sinusoidal functions to make everyone smile.
Oh, yeah.
All right. So what would you recommend here? We're going to make our D or our B value. What did we make it? 10. Okay. So that would be a pretty good answer. Now you'll notice that it's worth 2 marks. So what would be the 2 marks before, do you think? What do you think the 2 marks would be for? 1 for making it higher.
1 for showing your work.
No, 1 for making it, 1 for the A and 1 for the B. So you could get 1 out of 2 as well. And then it asks you to graph it in part E. I'm going to leave you that. Okay, you guys have done very well staying with me this period. If you really want to try some more, there's a couple more there for you to try. Monday, of course, is the barbecue. I'll be in here at lunch if you want to come and see me for some math help. I'll see you here in my spare as well after the barbecue on Monday.
You're going to be watching.
We're probably going to need, we're going to have to do lots of this on Tuesday and Wednesday. Would you like me to aim for the test on Thursday so we got 1 review day for the exam? I think so, right?
Well, we need a test. It's good.
I think it's